All right, so percent and proportion. Most of you guys are probably familiar with a percent. So we use them all the time. And you know, for example, that 50% means half, 100% means all of something. But it's also something that we can say that we're going to calculate in a more formal way. So I'm going to label this one 2 to correspond to that number 2 pencil thingy on the PowerPoint. And we're going to say this is for calculating percent. And specifically, the formula for percent looks like this. Percent is equal to 100 times f over n. So what do these things mean? Well, f is going to be your frequency. In other words, what we have listed in our second column of frequency distribution. And n is going to be our total number of cases or observations in a sample, which you find at the bottom of your second column in the frequency distribution. So total number of observations. And so if we want to calculate a percent, we can plug these numbers in for each of the different observations we have. So I'm going to write out our first frequency distribution again here. So we're going to a new page to do this. And so we'll say we've got our frequency distribution looks like this. Number of felony arrests, where the possible numbers of arrests we could have in our original sample here were 0, 1, 2, 3, and 4. And the frequency with which each of these things appeared, which in this one I'm just going to label as f to make it a little shorter. We have 4, 3, 2, 1, and 2. And as a reminder, that corresponds to this data up here, where we had 12 people who had different numbers of arrests in our sample. So let's say now that I want to know what percentage of people in the sample had 0 arrests. So I'm going to make a third column here, which I'm going to call percent, and you can just label with a little percent sign. So what percentage of people had 0 arrests in our sample? Well, we're going to use our handy-dandy percentage formula for this. So we know that the percent is going to be given by 100 times f over n. So we'll say we've got 100 times f, which is our frequency. So you see an f corresponds to the f in our frequency column. So we'll say that the f for 0 arrests is going to be 4. And we're going to divide that by n, which is the total number of observations in our sample, which is down here. So in order to find the percent here, we're going to do this math. We've got 100 times 4 over 12, and that comes out to 100 times 0.33, which gives us 33%. So we can say now that we have a sample in which 33% of people had 0 prior arrests. And now we can do this for all these other numbers as well. So we can find out what percentage of people had 1 arrest, we can find out what percentage of people had 2 arrests, what percentage of people had 3 arrests, and what percentage of people had 4 arrests. And so we'll plug in the same numbers. So for 1 arrest, we've got 100 times f over n. F for 1 is going to be the frequency in the second column that's next to the 1 in the first column, and that's going to be 3. And then our n is going to be the same for each one of these, because we only have one n in the table, and it's 12. So 100 times 3 over 12 is going to be equal to 100 times 0.25, or 25%. So 25% of the people in our sample had only 1 prior arrest. And I'll write this out for the other ones as well. I won't narrate quite as much, though, since it's the same procedure for each of them. So for 2 arrests, we have a frequency of 2. Plug that into our equation, we have 100 times 2 over 12, which is still our n, which gives us 100 times 0.17. And for each of these, I'm rounding to 2 decimal places, which gives us 17%. Same thing for 3 arrests, 100 times 1 over 12 is going to give us 100 times 0.08, which is going to give us about 8%. And then finally, we're going to have the same equation for 4 as we did for 2, since the frequency is 2 for both of them. So we'll have 100 times 2 over 12, which is going to once again come out to 17%, but I'll write it out. So that's it. We've made a relative frequency distribution. And I'm going to write this out a little bit more cleanly now without all this noise. So we have our number of felony arrests. Zero, 1, 2, 3, and 4. Our total, or n. We have our frequency, 4, 3, 2, 1, and 2, which comes out to a total of 12. And then we have our percent. So here we can say 33% of the sample had 0 arrests, 25% had 3 arrests, 17% had 8 arrests, 8% had 1 arrest, and 17% had 2 arrests. Finally, I'll also add the total here, and you'll note that it's always going to add up to 100. So we have a total of 12 cases in the sample, and if you count up everything, that's 100% of the cases in your sample, so your total is always going to be 100% when you're looking at the relative frequency there with percents. So this is with percents. As I mentioned, you can also do it with proportions. So I'm going to write out as a 3 here to correspond to that 3 pencil thingamabob proportion. And proportion and percent are really similar. They give you almost exactly the same information, they're just written a little bit differently. And the equation for proportion is actually a little bit shorter than the one for percent, because all we have is f over n. So your equation for proportion is going to be the same thing as your equation for percent, it just doesn't have that 100 in front of it. So if you wanted to add proportion onto this table, which we get by p, we're going to do just f over n with no 100. And we're going to be looking at the same number. So for 0 arrests, our f is a 4, and our n is a 12. So here we have 4 over 12. And so what you see is that we have the exact same thing here as we do here, there's just no 100 in front of it. So this is going to give us 0.33. And we can go through and do that for all the rest of these also, but what you'll notice is that it's the same exact number as we have for percent, it's just that there's a decimal point in front of it. So for this one we have 3 over 12, which gives us 0.25. For this one we have 2 over 12, which gives us 0.17. 1 over 12, which gives us 0.08. And 2 over 12, which gives us 0.17. Now if you add up all of your different proportions here, they should also add up to 1.0. So proportion, again, corresponds to percent, it's just a different way of writing it. And the main difference is that percent ranges from 0 to 100 and proportion ranges from 0 to 1. But they give you the same information. So a proportion of 0.33 is the same exact thing as 33%. A proportion of 0.25 is the same thing as 25%, and so on.